All right, chapter 4. So 4.1 is all about correlation. And these are the objectives. Number 1, construct scatter plots. Then compute the correlation coefficient R, and then interpret our results with that coefficient R, and then understand that correlation is not the same as causation. So objective 1, to construct scatter plots. Let's start with this example. So suppose that a real estate agent wants to study the relationship between the size of the house and its selling price. It is reasonable to suspect that the selling price is related to the size of the house. So specifically, we expect that houses with larger sizes are more likely to have higher selling prices, right? So a good way to visualize this relationship is with a scatter plot. In a scatter plot, each individual in the data set contributes an ordered pair of numbers, x and y, and each ordered pair is plotted on the set of axes. So let's say we have an example here. So the following table presents the size in square feet and the selling price in thousands of dollars for a sample of houses in suburban Denver neighborhood. We're going to construct a scatter plot for the data. So we have your size and the selling price. And I'm going to show you how to use your graphing calculators here. So first, to enter, it's the same process. It's stat 1. So enter the data. So the size, we have the first one by square feet, so 2521. So if you have your graphing calculator, you can do this at the same time. 735 2846 3028 3049 3198 and another 2198. And in thousands of dollars, the selling price. So the first one is 400,000, then 426, 428, 435, 469, 475, 488, and 455. So they're always in pair. So all you have to do to get a scatter plot, so second y equals, so second y equals, and then choose a 1. So that's the first one. And then make sure to highlight on. Like this one. So highlight, just enter to highlight on. And then you see the type. The first one is the scatter plot. And then X list, Y list, that's the default. So you don't have to change anything here. And then to graph it, should be zoom 9. Zoom 9. Okay, so that is the scatter plot. So second y equals 1, turn it on, and then to graph it, zoom 9. Okay. Any questions?
No.
Nope. So make sure that you know those steps to graph it, because I don't want you to spend a lot of time just to look for the points like 1, 2, 3, 4, 5, 6, 7, 8 points. And this is the easiest way. So by using a graphing calculator.
Okay.
Next, let's continue our PowerPoint.
When's classwork due?
What was that?
When's homework due?
Sunday is always Sunday.
Oh, okay. Thank you.
Yeah, for everything, all the chapter homeworks is always going to be Sunday night, so that
Okay.
we want to be consistent, right? So everything is always, yeah.
Yeah.
And same thing with the discussion. So let's say if I either started with on a Monday or a Wednesday, it is always due also on a Sunday. Okay.
Yeah. Thank you.
Yeah. So if you wanna check this PowerPoint, these are the steps again how to construct your scatter plot. So based on our scatter plot, you can see a positive linear association. So what is that? So observe the larger sizes tend to be associated with larger prices, and smaller sizes tend to be associated with smaller sizes. And we refer to this as a positive association between size and selling price. So in addition, the points tend to cluster around a straight line. So based on these points, when it looks like if you draw a straight line, it's going up. And for the next section, we're gonna get the exact equation of this line. So, but for now, so we can say that this is positive between the size and the selling price. So these are the possibilities. So if your scatter plot is like this, the points here, you can, it shows, let's say you can draw a straight line. This is a positively associated. If your points are like this, so definitely it's negative. And if, let's say your points are, you don't see a pattern, meaning this is no correlation. So positive, negative, and no correlation. Okay. So how do we compute our correlation coefficient? So a numerical measure of the strength of the linear relationship between two variables is called the correlation coefficient. So you can copy this. And we have a formula for the correlation that is our R. There is a formula for correlation coefficient R. This is the formula. But since we are using the graphing calculator, you don't need to copy this formula because that's a long method, right? So by using the your graphing calculator, all you have to do is just enter your data, just like what we did earlier, and then a few more steps you will be able to solve for R. And I'll show it to you after this. So again, this is the formula. You don't need to copy, but I want you to copy this. Properties of correlation coefficient. The first one, when you compute for your R, everything is between -1 and +1. Negative meaning that it's negatively associated, or positive correlation on the positive side. Again, your R should be between -1 and +1. R does not depend on the units of the variables, and it doesn't matter which variable is X and which is Y. So you can mix, you can either switch your two columns. The correlation coefficient only measures the strength of the linear relationship. You will see if it's positive or negative, or there is no correlation. And our correlation coefficient is sensitive to outliers and can be misleading when outliers are present. And I'll show you some examples of this later. Okay, copy and let me know when you're done.
I'm finished.
All right, let's wait for the rest. Need more time?
No.
No.
Are we good? Yeah, okay. All right, so computing the correlation coefficient R, I'm showing these slides showing with the formula. So with the formula, you're gonna need to solve for the mean of all your X values. By the way, this is your X and, oops, sorry. This is X, this is Y. So solving for the mean of all the size, and solving for the mean for the selling price. And also you need to get the standard deviations. So that's a lot, right? And then after you do that, by using the formula, you're gonna have to have 3 columns, and using this formula. So I don't want you to do this. I don't want you to spend so much time doing this. And I don't expect you to do this on a quiz or a test, okay? Because you're just gonna waste your time. So what to do is, to get the correlation coefficient R, let's go back to the example. And since we're using the same example, let's go back to our calculator. So here you go to, oh wait, since this is chapter 4, make sure that you go to your mode and then you go down to stat diagnostics and make sure to turn it on. Enter. Okay. Again, so make sure to go to your mode and choose stat diagnostics and then turn it on. And then after that, so stat calc stat calc 8. So I'm gonna so stat calc 8. Then X list, Y list, your X, that's the first column, Y list, the second column. And you don't, that's the default. And that's it, just calculate and you will see R. So this is the answer. Okay, so you can use, let's say 3 decimals. So with this 3 decimals 0, 5, so round off. So that's why it's 0.901. See? So enter the data, then start calc 8, and you will see the answer. That is without using the formulas. Okay? And you will see here the answer is the same thing with the formula, 0.9001. And that is our answer, 0.901. Any questions? So don't worry, you will get used to this stat calc 8 because I'm going to give you more examples. And for the other sections, we're still, for the whole chapter, actually, we're using stat calc 8. Okay? So again, the whole chapter, the shortcut is stat calc 8.
I have a short example that we could work out together.
Oh, yeah, definitely. We're going to finish this and then we're going to go to our ebook to work on those examples.
Okay, thank you.
Yeah, that's the plan. Okay, and the next one, interpret the correlation coefficient, your R. So how do you interpret our results? So if you want to copy this, if R is positive, just like what we got from the last example, 0.901, the two variables have a positive linear association. If R is negative, then the two variables have a negative linear association. If R is close to 0, then it's very weak. That's why I mentioned earlier that if the points are scattered and if you don't see a line, positive, negative, it's weak. So meaning there is no correlation, meaning it's very close to 0. The closer R is to 1, the more strongly positive the linear association is. If you see like most of the points is like this, most very close to line, just like the last example, that's why you will see 0.990 plus. So that is a strong positive linear, there is a strong positive linear association. If closer, the closer R is to -1, the more strongly negative the linear association is. If R is equal to 1, then that's a perfect straight line and positive. And if R is -1, also another perfect straight line with a negative slope. So copy those, how to interpret R. Let me know when you're done. All right. And the last part of this is understand that correlation is not the same as causation. Just an example here to understand that a group of elementary school children took a vocab test. It turned out that children with larger shoe sizes tended to get higher scores on the test, and those with smaller shoe sizes tended to get lower scores. As a result, there was a large positive correlation between vocabulary and shoe size. Does this mean that learning new words causes one's feet to grow, or that growing feet cause one's vocabulary to increase? So the fact that shoe size and vocabulary are correlated does not mean that changing one variable will cause the other to change. So take note of this, copy this. Correlation is not the same as causation. So in general, so when two variables are correlated, we cannot conclude that changing the value of one variable will cause a change in the value of the other. Okay, and let's have some examples here. Where's my... So by the way, if you go to your Connect Math, you'll see chapter 4 assignment, and I know there are only, I only assigned you 20 problems. And like what I said, don't forget, you always get a bonus of 3 points if you get at least 90% on the homework assignment. So always take advantage of that. It will help you a lot. Where's my book? All right, so let's try, please get your graphing calculator, and let's try number 31. So price of eggs and milk. So the following table presents the average price in dollars for a dozen eggs and a gallon of milk for each month in a recent year. So try this. This should be your L1 and your L2. So enter those numbers. Then construct a scatter plot. So this is the shortcut. Second y equals 1 on, highlight on, and then zoom 9. Okay, so when you, do you have the scatter plot now?
Yes.
Yes, what do you see based on your dots? Is it positive or negative?
Positive.
Okay, so we will see, and we will check if it's positive. Letter B, compute your correlation coefficient. So remember the shortcut, stat, arrow to the right to highlight calc, and then 8. Oops, sorry. Calc, and then 8. And you want to get the value of R. What is your answer?
R equals 0.845.
Yes. Very good. So that is correct. So use 3 decimals. So R is 0.845. Okay, so since this is positive, so yes, that's correct. Your scatter plot should be positive. Questions?
After I do the step for the scatter plot, step B isn't working for me for some reason.
The stat calc 8.
Yeah, I type that in and then it just gives me an error.
Were you able to get the scatter plot?
Yes.
Yes.
When I push stat and then go to calc and push 8,
Yeah.
it says LINREG and then parentheses A plus BX parenthesis. And then if I push enter it, am I supposed to enter something there?
Are you using online or do you have your own graphing calculator?
I have my own.
What calculator do you have? TI-84 to TI-83?
TI-84 plus Silver Edition.
Okay.
I can totally just ask this after class too.
No, that's fine. It should be when you start calc 8. What do you see?
LINREG, LINREG, and And then I see a parenthesis A plus BX close
Yeah.
parenthesis.
Do you see anything below that?
No, it's all blank with the option to type something. A while back, you had us change something because we're on chapter 4, and my calculator didn't have that option, so I'm not sure if that makes any difference.
Okay, so how about try this? So you said stat calc 8, you see line reg A plus BX, right?
Yes.
Type L1 comma L2.
Okay.
So second 1 comma second 2, and then enter.
It's still an error. Oh, hold on. Let me do that one time. For some reason, L1 and L2 aren't showing up. So mine is L2 and L4. Let me do that real quick. I have to go back. So, second, Y. Okay, so stat. Okay. That brought it up.
So you should be able to see R, right?
Yes, I have R now. Thank you so much.
Yeah, no problem. Carlos, what's your problem with the online? It should be exactly the same as what I showed here. So what do you see? Are you good now? Okay, so let's try one more. How about number 37? All right, so blood pressure. A blood pressure measurement consists of two numbers, the systolic pressure, which is the maximum pressure taken when the heart is contracting, and the diastolic pressure, which is the minimum pressure taken at the beginning of the heartbeat. Blood pressures were measured in millimeters of mercury for a sample of 16 adults. So the following table presents the results. So enter all this. So this is like your L1, systolic pressures L1, and this is L2. This is a continuation of L1, and this is the last column is a continuation of L2.
In line 1, do we add both systolic lists?
Yes.
Okay.
So it says here we have a total of 16 adults. So this is a continuation.
Got it. Thank you. I'm sorry, is the top of the second list 183 or 133? I can't tell with the mark.
It's 183.
Thank you so much.
Oh, 133, sorry.
That's okay.
So practice construct a scatter plot. And that's for letter A. So you should have a graph, a scatter plot. And B is your correlation coefficient R. So Thelma, what we want is the R.
Is it 0.857?
857, yes. 0.857. So again, I use 3 decimals. So that's why your A scatter plot should be positive, right? Did you all get the same answer? 0.857? Yes?
Yes.
All right. Any questions? This is 4.1. So again, StatCalc 8, that's the shortcut. I don't want you to use the formula. And all right, so since you don't have any questions, we can go to back to our PowerPoint and continue with 4.2. And this is all about the least squares regression line. So since Thelma showed A and B, actually we need those for this section. And for those two things, when you compute your R, StatCalc 8, above you will see A equals B equals, right? And that's what we need for this section. So compute the least squares regression line. So meaning we need to write the equation of the line. So in algebra, I'm sure you remember this. What's the equation of a line again? Do you remember?
Y equals mx plus b.
Yes, very good. So y equals mx plus b. And, or ax plus b, yes. M is the slope and b is the intercept. So here, we're gonna use the same equation with different variables. So compute the least squares regression line, that's the first thing, and then use the least squares regression line to make predictions, and then interpret the predicted values, the slope, and the y-intercept. So yes, when you use StatCalc 8, you'll see above y equals ax plus b. So let's compute now the line, the exact line of this same example. So remember from 4.1, the house size versus the sales price. So you know how to get this scatter plot. So the table presents the size in square feet and selling price in thousands of dollars for a sample of houses. In the previous section, we concluded that there is strong positive linear association between size and sales price. So we can use the data to predict the selling price of a house and based on its size. So to compute, it's the same thing. I'm gonna show you, I'm gonna go back to calculator. Since I still have my data here. Yeah, is it the same? Yes, it's the same thing. So again, StatCalc 8, and then this one, sorry. StatCalc 8. Calculate. So we have our A and B, and so this is your guide here. Y is equal to A plus BX. So meaning you just need to copy in this format, y is equal to a plus bx. So your least squares regression line is equal to y equals a is 160. So copy 160 point. Plus your b is 0.0, let's use 4 decimals, 0.0 992x. So you just have to copy your a and your b, and this is your least squares regression line. Okay, so it's the same shortcut StatCalc 8. And what you're going to do next is when you have this answer, so go to press y equals on the very top left here, your calculator, and you just have to enter your equation here. You see y1, enter the equation here. So 160.1939 plus 0.092, and don't forget the x. Oops. 160.1939 plus 0.0992. X is this one. On the top left, you see alpha. Next to alpha is the x. Okay? After you type the equation here, so again, zoom 9, and you will see the graph. So that is the exact equation of the line. Any questions? So again, StatCalc 8 to get a and b, to write the equation of the line, and then press y equals to enter that equation. And then again, zoom 9 or just graph, you will see the line. Okay, so that's how you construct a line. So in addition to your scatter plot. So since I showed you the least squares regression line, so this is some examples. So just like this one, this is on the left side here. This is our exact example, the line. So the figures present scatter plots of the previous data, each with a different line superimposed. It is clear that the line in the figure on the left fits better than the line in the figure on the right. And the reason is that the vertical distances are on the whole smaller. You see the distance from a point to the line. It's very close to the line compared to when you draw a line this way. So that's why it's obvious that it is positive, right? And again, this line is we call least squares regression line. And there are formulas for, actually this is, in statistics, this is the least squares regression line. You'll see in all statistics books, instead of y is equal to a, remember earlier, a plus bx. So this is our formula for least squares regression line. So y hat is equal to b0 plus b1x. So b0 is the a, b1 is the b. So again, bo is the a, whereas that is the slope. v1 is the intercept. And these are the formulas, but we don't want to use this, right? So StatCalc 8, you'll be able to get our equation of the line. Okay, and also on your homework Connect Math assignments, I'm not gonna, don't expect that I'm gonna ask you to use formulas. So you don't need all this because again, I showed you earlier, I already showed you how to get the equation of the line. So this is the equation of the line. So 160.1939 plus 0.0992x. Don't forget to the x. And if you want to practice, these are the steps using, again, your graphing calculator. Okay, next one is how to make predictions with those least squares regression lines. So meaning, how do we solve a predicted value? So whenever we have an equation, just like this, the predicted value is the y hat. So we can use the least squares regression line to predict the value of the outcome variable by substituting a value for the explanatory variable in the equation of the least squares regression line. So all you have to do is, like an example here, so the equation of the least squares regression line is this. And the question is, predict the selling price of a house size 2,800. So all you have to do is substitute 2,800 to x. So now you can compute for the predicted value. So 160.1939 plus 0.0992. So just substitute the selling price of with a size of 2,800 square feet. So try that, use your calculator. What is the answer? So 160.1939 plus 0.0992 times 2,800.
$437.954.
437.9. So let's round up to a whole number. It's just going to be 438. Yeah. So meaning the house with a 2,800 square feet, approximately the price is 438,000. Any questions? Oh, actually, we have the answer is here. So you see the point here. So at 2,800, and that is equivalent to 438,000. All right, next is now you know how to solve for the predicted values, that is the y hat. You know how to get the slope, which is, okay. So with your graphing calculator, when you use a StatCalc8, you will see y is equal to a plus bx, right? So this is the predicted values when you substitute a number to x. the slope is A, and the y-intercept is the B part. So how are we going to interpret those values? Okay, so the predicted value y hat can be used to estimate the average outcome for a given value of x. For any given x, the value y hat is an estimate of the average y value for all points with the x value. So let's try this again with using the same least squares regression line equation. So predict the selling price whose size is 3,000 square feet. So do the same thing, just like what we did from the previous problem. So this time, what is the predicted value with size of 3,000 square feet? And let me know when you have an answer. All right, so for 57.8 or 450, almost 458,000. So that's correct. So we estimate the average price with a 3,000 square feet to be $458,000. Okay. So again, I'm not strict about the decimals. So if you have 1 decimal, 2 decimals, or just 1, or no decimal, I will accept that. Okay. But for R, let's say for quizzes and tests, let's be uniform. Let's use 3 decimals for R. So next one is how do we interpret the y-intercept? So I want you to copy this. I'm sorry. So the y-intercept is the point where the line crosses the y-axis. That is the point on the y-axis. And to interpret that, if the data contain both positive and negative x values, then the y-intercept is the estimated outcome when the value of the explanatory variable is 0. If the x values are all positive or all negative, then the y-intercept does not have a useful interpretation. Okay, for example here. So interpret this slope, which is B1, your A. If the x values of 2 points on a line differ by 1, the y values will differ by the amount equal to the slope of the line. And the formula for this is the slope times the difference between the two. So an example, 2 houses are up for sale. One house is 1,900 square feet in size, and the other is 1,750 square feet. So by how much we predict their prices to differ. So first, what's the difference between the sizes? So subtract the two. 1,900 minus 1,750 is 150. And then based on the formula, slope times the difference between the two. So the slope is from the same equation, 0.0992 And then the difference D is 150. So multiply the two. So that's why the answer is 14.9 or $14.9 thousand. Any questions? All right, and that's it for 4.2. So I'll show you examples from the book. Especially with those interpreting slope. Oops, it's 4.2. Mm. 23. All right, pass the ball. So the following table lists the heights in inches and weights in pounds of 14 National Football League quarterbacks in 2016 season. So again, please get your graphing calculators and enter this into L1 and L2. The height and the weight. And then next is compute the least squares regression line. So you see letter A, the question, meaning the equation of the line. So shortcut again, StatCalc 8. And you should see on top of your screen the pattern y is equal to a plus bx, right? So just copy a and b. So what is a?
Negative 146.7663551. I mean, round it up, right?
Say that again, 76.
7663551.
7664. So let's use 4 decimals plus what is your B, which is the slope?
4.943925.
Before
234.
So 9,
Oh, okay, my bad.
9.
9439. Yes.
So this is the equation, the least squares regression line, and that's what we want, right? Did you get the same thing? Again, make sure that you have, this is practice. And then to answer the next questions, is it possible to interpret the y-intercept? Is it possible to interpret the y-intercept? So remember how
Yes,
to,
it is.
how to interpret the y-intercept. Okay, so just to recall.
Is it possible because the data is between positive and negative, both positive and negative?
So that part. So here, it's possible if both positive and negative x values, if and then the y-intercept is it's possible. If the x values are all positive or all negative, then y-intercept does not have a useful interpretation. So our data for a number 23, when you enter the height and the weight, so what do you think? Is it possible to interpret the y-intercept? So again, you entered your data, height and weight. So based on either of these two, to answer the question, is it possible to interpret the y-intercept?
No,
Why not?
because all the values are positive.
Yes. Okay, so because your x values are all positive. If they're all positive or if they're all negative, then the y-intercept does not have a useful interpretation. So the answer for letter B is no. Okay, so let's go back to the question and answer letter C. If two quarterbacks differ in height by 2 inches, so 2 inches, differ by 2 inches, how much would you predict the weights to differ? So remember the formula. What's the formula for this?
B1 times D?
Yes, B1 times D. So whenever you see differ, so that's the difference. You need to get, this is the formula, B1, the slope times D. So from letter A, our equation of the line was -146.7. What was that again? Sorry. What are the decimals again?
7664.
7664 plus 4.39x.
9439.
So the slope is 4.939. So to use this formula, so 4.9439 times, it says here the difference is
2 inches.
2 inches, yeah. So just multiply it by 2. And answer?
9.8878.
8878. All right,
Yes.
thank you. Okay, then letter D, predict the weight, who is 74.5 inches tall. So what do we do here? Predict, so meaning to compute for the predicted value. What do we need to solve that, to answer that?
You would substitute the number for x.
Yes, substitute 74.5 to x. Predicted value is the y hat, so you need to compute for y hat. So -1 for 6.7664 plus 4.9439 times 74.5. Answer? Answer?
Would it be 221.55?
By the way, when you use a calculator, the negative is not the minus sign. The negative is next to a dot. You see it below 0, 1, 0 dot, then that is a negative. Okay, so using your graphing calculator to enter at the negative, it should be this key. Look for this key. That is the negative. Okay? So 221.55. Thank you. Then letter E, Kirk Cousins is 75 inches tall and weighs 214 pounds. Does he weigh more or less than the weight predicted by the least squares regression line? Kirk Cousins is 75 inches. Look at the table here. Kirk Cousins 75 inches, and that is 214. So does he weigh more or less than the predicted value?
He weighs
Less than.
Hmm? Say that again.
He weighs less than.
Yes, less than. Okay. Any questions? Let's have another one. Last one. Last one for today. I want the 27. Let's go back to systolic blood pressure. So it's the same problem, but this time instead of scatter plot and R, we need to get the equation of the line. To answer, it's possible to interpret the y-intercept, also the slope and the predicted value. Okay, so try to enter those numbers again into L1 and L2, and we will answer A, B, C, and D.
I have a quick question. On that one, since it's continuing, we can pretty much put systolic together. That way we don't have different like L1 through 4, let's say, right?
No, it should be L1, L2 only.
Okay. Okay. Thank you.
So it says here also, don't be confused, good question though. Don't be confused when you see on a quiz or homework or a test. So look at it, a sample of 16 adults. So meaning per column, you should have 16 numbers. Like this one, 1, 2, 3, 4, 5, 6, 7, 8. So that's why this is a continuation of that. 9, 10, 11, 12, 13, 14, 15, 16. Okay, so this should be L1 and this is L2. Let me know when you have an answer for letter A. What is the equation of the line? Thelma, no, equation of the line. So we need in the form of y is equal to a plus bx. So this is the hint. Pay attention to the question. So let's say compute, this is the hint, compute the least squares regression line, meaning we need the answer in this form, y is equal to a plus bx. So when you use StatCalc 8, so you just have to copy A, what A is. So yes, 9.1828 plus your B is 0.574. Is that 7 or 8? 8, yeah, x. So this is the equation of the line. Okay, so whenever you see this, compute the least squares regression line, meaning we want the equation of the line. Letter B. Is it possible to interpret the y-intercept?
No.
Why not?
X values are all positive.
Very good. And then letter C, if the systolic blood pressures of two patients differ by 10, by how much would you predict their diastolic pressures to differ? So remember, this is P1 times D, right? So your B1 is 0.5748 times, what's the difference? What is D?
10.
10. So when you multiply that, is 5.748. And letter D, so whenever you see a question like this, predict, meaning you are solving for y hat. Meaning whatever your equation is, you just have to plug in the number to x. So 9.1828 plus 0.5748 times 125. And the answer is
81.0328.
or 81. Okay. Any questions?
Do we always round the y hat to a whole number?
Not really. So you can it depends on the problem, but this one should be a whole number because look at your diastolic pressures is all whole numbers. So that's why you can round it up to whole numbers.
That makes sense.
Okay. Since look at the given, everything is whole number, so that's why you can round off this to whole number. But again, I'm not strict for your quizzes and tests, even if it's, you have 2, 3, or 4 decimals. Okay.
Okay.
Any questions? Any other questions?